So, just as I had left on my long 2.5, 3 week vacation, every single person I've ever met started playing the same game. And I was on the road with a laptop, so I couldn't join in any of the fun. But when we got back, I picked up Kerbal Space Program because I had to see what all of the fuss was about. And in the last couple of days of tinkering with it, I found some cool tricks. So I thought maybe we would do a little Toy Makers mini series here, showing you guys some of the stuff that I learned. So I'm going to resume saved here, and we've got Toy Makers Space Agency, that's TSA for short. None of our Kerbals are allowed to go into orbit with toothpaste or fingernail clippers for their own safety. So, just started. I have not actually gone into it yet. We're going to go in there, and so basically on this screen here, we've got the space plane hangar, the vehicle assembly building, the launch pad, of course, our flag, the runway, and the tracking station. Now, I'm not so interested in the space plane stuff, but I have been having a lot of fun with rockets. So, what I'd like to show you guys here is how I've been putting together. I've heard people call it asparagus staging, and it's a creative way of pumping your fuel through your various stages into the center so that when you drop your tanks, the tanks that you still have remaining on your vehicle are still full. So you can put some sort of a capsule on here like any of these guys, and this is what your little Kerbal Space dude would ride around in, is this thing. But I really kind of like working with these remote guidance units. So this means that it's basically a robot, and we're talking about a space robot. How cool is that? So these things need power, though. So the first thing I add to them is a battery pack, which we can find here. And everything just sort of snaps together. Yeah. So a battery pack, and we need some way to charge it. I tend to use these solar panels right here. They're a little bit big, though. They don't necessarily fit perfectly on that. So what I like to do is take one of these RCS fuel tanks. Now, RCS is what allows you to maneuver and translate yourself around once you're up in space, typically, and I tend to use the heck out of it. So one of the first things we're going to do here, while we're building this, is because I'm such a noob, I have to turn on one of these cheats, which is infinite RCS. Now, I don't want to turn on infinite fuel or anything like that, or any of the really cheaty stuff, because that's no fun. But I still have to use a lot of RCS because I'm really not very efficient at how I do my orbital docking yet. I've only done it a couple of times, so hopefully I'll be able to get better. And to bring up this cheats menu, it's very simple. It's just Alt F12. Thank you for Brainwagon for cluing me in on that little trick. I'm sure he probably cheats horribly because he's a cheater. Okay, so we were doing solar panels. Okay, so I got my solar panel here, and I want to surround this RCS tank with them. So what I'm going to do here is throw this into symmetry mode so that I've got 4 and have it snapping to the angles. So I can very easily just come in and pop on 4 like so, and another 4 right here, another 4 right there. So now I've got power coming into this battery, which is powering my remote controlled unit right there. So very, very efficient, compact design. So the next thing we need to add here is in the control system, we need this advanced SAS module. And this is basically, it automatically adjust your pitch, roll, and yaw to keep you pointed in the direction that you wanted to be pointed in. And this is absolutely, you can't, if you're new to flying space vehicles, you just can't get away without having that thing. I know some of the old school players don't even like to use this thing because they got so good at doing it by hand. But yeah, I am not that hardcore. So we'll do it like that. And we were talking about that RCS stuff. So this is an RCS thruster, and we're going to put these on our spacecraft, and we need to have 4 of them because what these do is help us translate. So if you were to like press J on your keyboard, this jet is going to turn on and this jet is going to turn on, which will literally push your spacecraft this direction, which is very handy. So you can go forward, backwards, left, right, up, and down. You get all 3 axes covered by placing 4 of them in a ring like this around the center of your craft. Now, one important thing to note is that if this were our entire craft right here, we'd run into problems because the RCS jets are on the back, which would put a tilt onto our spacecraft overall. But if they're in the center, they just push us side to side, up and down, so on and so forth. So we need to make sure that these things are at the center of our mass. Kind of important. So we are not done building down, so it's going to be just fine. Let's get ourselves a small fuel tank there. Pretty easy. And I like to add another small fuel tank underneath, not so much for the fuel capacity, but to create a nice mounting point for our very small engines right here. You see those? It allows us to keep them inside here. Now with these engines, you've got really gigantic engines, and you've got the little tiny ones. But one of the things to note is that this one has something called thrust vectoring. And I'm sure you've probably seen videos of this happening on jets and spacecraft and things. Thrust vectoring is when the nozzle on the end of the engine can rotate around so that it can basically maneuver the craft slightly just by changing the direction that the nozzles are making the exhaust go out. So by having 4 of these little engines, each one has 20 is the max power. I have no idea what these units are in real math, but 20 is the max power. We have 4 of them, so that's 80 is the power on this. And the tank that we used is a very small tank here, and that holds 90 fuel and 110 oxidizer. And the tiny one that we added on there only holds 5.735 fuel. So it's very, it doesn't even matter that it's there. It'll get all eaten up very quickly. All right, so there's our basic craft, and this is essentially what's going to be up in orbit, maneuvering around. Now we need to build in a way to get it to orbit, and this is much more tricky. We have to lift this mass up, way up into the sky, and that is no easy feat. So what we're going to do here is we're going to add some structural elements that allow us to decouple stages from us as we're going up, so that the higher we get, the lighter we get. And as our fuel tanks become empty, we can drop them. And that's very, very useful, because the lighter we are, the easier it is for us to get ourselves into orbit. All right, so I'm going to place, I think that should probably do. I'm going to double check here. I think it may be 1 tick over. this is more advanced what I'm doing right now. So we've got one of those, and it's a pair. So it comes on both sides, and it's very important that you do it this way so that we can stage our pieces as they come off. Yeah, I'm gonna have to go wider. Oh well, we'll still be able to get off the ground with this thing, but we have to keep it balanced. If the engines are unbalanced at any time, our craft will absolutely blow apart and create an amazing fireworks display, which, by the way, is fun to do on purpose occasionally. Yeah, this is not liking my pattern. Not at all. We're just going to have to center this one, I guess. Okay, so I just built one of these in a larger version, and I was able to get a lot more of these layers on. So this is the basic, what we've got here. And these structural elements that I just added, what they do is they allow you to decouple whatever's attached to them. According to a program that you put together here on the side. So what we'll be doing with these is breaking them down into stages that we can step through as we're launching our craft into orbit. Now, we obviously need to attach things to this. So what I'm going to use here is this I-beam, and I'm going to attach it to each one of these staged couplers, and I'm going to rotate the part outward by hitting the W key while holding it. And then I'll pull another one and place it here, and the same trick with the W. And we want to make sure that we keep these as centered as we possibly can. It's absolutely catastrophic if things become out of balance. So it doesn't have to be completely perfect because we have that SAS system and the RCS system installed. That'll help with a few of the wobbles, but in general, it's just a good practice to keep everything as balanced as you can. Okay, so there's our struts going out. Looks like we picked up a stray somewhere in here. Okay, so you're getting the idea there. These I-beams will disconnect and fall off when this is triggered, and we'll be programming when those are triggered over here on the side. So now we have our structure in place. Now we need to attach some fuel so that we can get this guy going into the air up high enough so that I can actually get into orbit. So I'm continuing with the pattern of pairs. See those two come on together. And now here's where we start in with our asparagus staging, which is a tricky way of dealing with fuel management when you're on your way up. I'm going to add a fuel line that's pumping from this tank into the core tank. And sometimes you have to do it a few times when it's close there. It's connected to the correct tank. You always have to make sure that it found the right thing to connect to. So now that we have that one, we can add the next one to our mix here. And I am going to pump from that tank over into this one. So as this engine is running and using fuel, it's going to borrow fuel from this one. And this one, as it's running, is going to borrow fuel from this one. And then our first or final, depending on how you want to look at it, final in the order that we build it, but first one to get emptied as we're flying is supplying fuel in this direction. Okay, but this one is not going to be having fuel pumped into it from anyone else. So naturally, this one will be the first pair to become empty, and as soon as it is empty, we will disconnect them using these, and they'll fall off. And when we do that, this tank will still be full because it will have stolen all the fuel from this. And when this pair becomes empty, we will drop them off, and they will have constantly been refueling this pair. And then we use up the fuel in these, and we drop them, and then at that point we still have a full tank of gas in the center. And the entire time we've been using fuel from all of these. And here's the next trick. What we're going to do here is take some more of our little engines and place them on these pairs. So are you figuring it out, everyone? As we go up, we're not only pumping our fuel inward, but we're using the fuel on every single pair as we go, so that we can have more engines running during the low points of our ascent, where we need a lot of thrust to push through the atmosphere. But as we get higher into thinner air, we drop our extra engines and become much lighter. So here's what we have so far. Isn't that nifty? Okay, so for aerodynamic purposes, what we're going to do here is add some nose cones to our pairs, like so. Looking good. And we need to add some way for this centerpiece, which will be all that's left when it gets up into orbit, to dock to other items up in space. So we're going to add a shielded docking port to the top of that, which has some aerodynamic capabilities too, I guess. So that's pretty much it, I think. And we need to do the programming on our stages next, so that everything falls off in the right order. Now we want all of our engines to turn on simultaneously, so I'm going to pull the original 4 engines down here into the engine enabling stage, and then I need to break apart each one of these. So this is our first pair, this is our second pair, this is our third pair, and we want our third pair to be the ones that fall off first. So we're going to add a stage, and I'm going to pull that one down, and you can see as I mouse over it, it highlights which one it is. So that one, and let's see, the last stage, that's from the first stage. So these two need to come down here. So the first time we start all of our engines, the next step is to disconnect this pair. The next step is to disconnect this pair, and then the next step is to disconnect that pair. And hopefully, with any luck, we'll be high enough at that point that we'll actually be able to put ourselves into an orbit. So before we do anything here, we have to save this. I'm going to call this the Probe Lifter 1, because I'm very, very creative. And then we're going to save it, and we're going to hop on over to the launch pad. Okay, when you're at the launch pad, it takes a second before it starts simulating, and when it does, you'll see things start to wiggle and move and whatnot. Now, when you hit M, it brings you out to the map view. Now, we're going to be launching into an orbit around this planet, and we're going to try to keep it right along with the equator, in line with the orbit of the moon here, and that's MUN. So we're going to kind of keep our orbit around the planet this way, and when we come up, we're going to be curving our orbit that way. So we need to make sure that we put our camera in a position where we can very easily see the arc of our orbit as we come up. So I set this up in advance, and I open up this control area here. on the map. By default, it's closed, and I think that should probably be opposite. If the developers ever hear this, having that up by default would probably be better, because having to open it every single time you launch is a little annoying. Now, I am going to turn on the SAS by pressing T, and that may be a little a strange place, a strange letter for it, but when you look at your keyboard, WASD, R controls RCS, T controls SAS, Q and E, roll you around. It's all built to be able to fly easily with your hands. So T is how you turn SAS on, whatever. Now, shift up, control down on the throttle. Pretty easy. We're going to max out our throttle. Okay, so I've got SAS on. The throttle's all the way up. Now I hit M to go back to the actual launching pad. Set my view up conveniently here. Now, when I want to start our first stage of our staging, I have to press the space bar, and that will step me through to the next phase when we're ready to do that as well. So I'm going to hit this. The engine's maybe a little loud. Be prepared. Okay. Now we're watching our surface speed. We want to keep that not crazy. 200 is plenty. Our fuel tanks are empty. I hit the space bar, so we're watching along here to see when the tanks are empty. Adjusting the volume here a little bit. Okay. So we're cruising straight up at about 180 meters per second. Drop down my throttle a little bit, because we don't really need to be going that fast because we're in atmosphere, and atmosphere adds resistance. We would rather save that fuel for when we're higher up and use it up there where we can much more efficiently turn fuel into delta vector, a change in your velocity. Delta velocity, rather. Okay. So this is the thrilling part where we get to go straight up for a bunch of time. Now, I have SAS on. And to momentarily disable SAS, you hold down the F key. I hit the F key, it turns off. Now, you kind of have to do that when you're making adjustments. I'm going to use the D key to roll my position this way along the 90-degree line, because we want to stay in line with the equator. So I have to hold F and D at the same time to roll this thing off to the side. And I've inverted my my up and down, so my W and S are inverted to make it easier on my brain. I don't want to go that far. I want to go to about here. Okay, we're about to run out of fuel on this set. Drop those. We're down to just our core unit. I hit M. You can see our highest point here in our arc is at about 30 kilometers, and that's not nearly high enough to be in orbit. But we still have a lot of fuel. We'll see how it goes here. We may not be able to get into orbit this time. Ideally, you want to get up to like 60 or so, so you're up out of the atmosphere so that it's not slowing you down. I don't think we're going to get there this time, but this is just an example of the basics on how to build something. Okay, X halts my throttle instantaneously, which is very handy. Now I can zoom out after setting this maneuver point, and this adds velocity. And this one shows me my closest to the planet on that side. I want to set that up some above 60. I'm at 70 there. So that adds a blue target, and I want to point at the blue target on the ball here, the nav ball. And then I want to thrust towards that blue target. Okay. And this is how many meters per second of change I would have to induce to actually make it to my target velocity. And we didn't make it. We just didn't have enough fuel. So I turn on RCS and I push my jets in that direction to try to bring it up. But you can see it's going so slow. It doesn't have enough thrust to actually bring me up to my target velocity in time to do any good whatsoever. So basically what's going to happen is my poor space probe is going to follow this curve and it's going to splash down in the ocean right there. So most of the launches that you attempt to do in this this game will probably fail. Lots of experiments. So I hit escape, I end flight, and now I'm going to show you guys how to modify this simple craft so that it has enough oomph to get all the way up there with no problems whatsoever. And basically the only problem that we have on this one is that we weren't carrying enough fuel to get up. So I'm going to try to add just twice as much fuel on the outside from what we had the first time around. And we can stack those up just like so. And when we get the tanks in place, which is sometimes a little bit challenging, when you start working in pairs like this, it gets a little confused at times. So we get those added, and then we'll add our nose cones right back to the top. And there we go. And aerodynamics tab. There's that. There's that. There's that. Okay, so this is our revision 2. Probe lifter 2, we'll save that one, and then check and make sure nothing got messed up in our programming. And you notice when we come back, it put these things into the right groups, unlike before. It should just do that originally, but hey, whatever. It's alpha software, you can't complain. Okay, so we're going back to the launch pad, and once again, we have to change this so that it's actually displaying. And then we have to adjust our viewpoint, turn on SAS, back in here, throttle up, and off we go. I'm going to throttle down earlier this time. We really don't need to be going more than about 100 to 150 meters per second to get up there. Riding the throttle can make your fuel use much more efficient. Okay, there's our first stage off. And we stage them the way that we did so that as each stage comes off, it's still completely balanced left to right on the craft, which keeps it controllable and keeps it from flying off in crazy direction. As you can see, we're going up much slower this time because I'm using my fuel efficiently and not letting this thing go up out of hand to like 400 meters per second or whatever we did last time. At about 10,000 meters, I'm going to start rolling along the 90-degree axis. This is the axis of the equator this way on the nav ball. Okay, right after this stage. Okay, now we'll start laying her over. Right to that 45 degrees over. You can see here it's 40, here it's 50, this line is 45. I like to stick it between 45 and 50 right in here. Seems to work pretty well. And when you're going sideways, this is showing your surface relative, the speed relative to the surface of the planet. So this number goes up, and you sort of have to look up here to see what your altitude change is on this meter. So as long as we keep that thing pointing just a little more than 100, we know we're okay. And let's see where our top is at. Right now it's about 21 kilometers. You can't see the resources unless you open up this on your map. Then you can see the fuel tanks going down. But when you're doing the asparagus staging stuff, it's kind of hard to read this. So I still have to switch back to this view. Okay, let's see where we're at. 27. And our atmosphere, we're about half of normal surface air pressure. The higher up we get, the more efficiently we can turn fuel into thrust. So it's okay to bring the throttle back up once you're up in the air like this. The higher you get, the more so that becomes true. And we're gonna kill our throttle when we get this up to 60 or so. And you could hear that. We ran out of fuel on that stage, so we'll knock it off. Those will fall back to the surface. And we need to set up our maneuver point right up there at the top. Bring our forward velocity up. 18 is too low. 59, 70. 60, 55, 63. Okay, that should be high enough for a stable orbit, just barely. So we'll bring that over to our target. All right, T-minus 36 seconds till our burn should start. But it's a long burn, 59 seconds, so we're just going to start that now. And we want to thrust completely on. There's some of our debris from our last attempt. So you can see that this is on its way down. When it gets down to the bottom, that means we've successfully completed the maneuver. And we may have enough fuel to do it this time. It looks like we will. Okay, there's that. Now if we go to the map, we'll see that we have a nice round orbit. Close that previous maneuver point, and you can see that we've got a nice round orbit around the planet. All right, so there's our little space probe. Now, one of the things that we can do very cheaply here is that if we go off to like this point here at 87.58, we want these to be the same. So if I add a maneuver point here and then push this out, you'll see that it pushes the orbit directly across the planet from it outwards. And 88 is pretty close to where we were before. So now we can do a little bit of time acceleration. Let me get my craft here pointed at the target. And that's the direction we want to be pointed to make this maneuver. And now I can time accelerate using the less than and greater than symbols. So I'm able to get up to 4x. The farther away from a planetary body you are, the faster you can accelerate. Right now we can only go 4 times. So it's going to take a little bit. So we can get around to there. And then when we get there, just by adding 23 meters per second, we'll be able to lift that side of the orbit up by 30 kilometers just with a tiny, tiny bit of energy applied. So knowing how to adjust orbits efficiently like that is one of the huge, huge parts of being able to achieve things like stable orbits and rendezvousing with multiple crafts coming together and plotting trajectories out to the moon and the other planets. So let's see, we've got 8 minutes, 1/4 of that. So we got about 2 minutes to kill. So here's the moon out here, and we've got another lunar body here, Minmus. And if we scroll out even further, you'll see that we're actually in a little solar system here. And there's Eve, Moho, Duna, Drez, Jewel, Elu, and I think that's it. So there's a whole lot of stuff to go explore out there, but that's beyond the scope of today's little introduction to what the heck this program is. Let's see if we're high enough up to... Yes, we are. Now we've got more arrows up here, which means we can accelerate faster. 3 minutes, 2 minutes, 1 minute. Bring down the acceleration. We've got 40 seconds. Now I'm going to use the RCS thrusters. Oh. I missed my maneuver point because I was accelerated. If you're accelerated and you go to change your thrust, it just doesn't work. So that's a good thing to know. But I can still add a maneuver point here and do the same thing. 91. These allow you to rotate the orbit this way. These two blue ones. Like so. Takes a little bit to get used to these, but once you get the idea, it's pretty easy. You can go crazy, and you notice the more crazy you go with your adjustments, the more it costs here in meters per second. We're in a stable orbit though, so we should be able to just leave this alone and it'll be fine. One thing I do wanted to note with the orbits though is when you're maneuvering, if you go sideways like this, you can see we're a little bit off from the orbit of the moon, and these purple ones are what adjust that. See? Dotted line is now flat with them. If I roll my nav ball around down here and look for that target, I can adjust the I think that's the inclination of the orbit. I'm not a rocket scientist though, so it could be any number of things. Using my RCS thrusters to just, because it's only like 20 meters per second that I need to change, the RCS thrusters have enough oomph. Okay, so now our orbit's much closer to that of the moon. We could probably even tweak it a little more. So yeah, that's the basics here. And when you want to go, like if you wanted to leave this guy up in orbit, he should be okay because he's got the solar panels, and you can see how much battery power is on here. He's losing batteries, but this thing has quite a bit of charge in it because it's charging due to the solar panels, and because we're out of the atmosphere, we can open the shield around our docking bay Now, if we were to come up here with another one of these guys, we can actually hook them together and start building some sort of a useful space platform. And I think we'll work towards that, but not today. So I'm going to go back down to the Space Center, and you'll see that if we go into the tracking now, we've got one flight in progress, Probe Lifter 2, and we can see it's his orbit there. And as we bring other things up, they will all show up in this list. And we can just leave them up there and build our next craft, whatever we're going to do. But I think that's it for this time. We've covered all the basics pretty effectively and efficiently. Let me know if you guys want more of these or not. If you do, I'll be happy to put them together. Thanks for watching. I hope you guys enjoyed this, and I'll see y'all later.